So much for joining us today. I know that there are a ton of other places that you could be spending your time, but you've chosen to spend it with us. And so I'm definitely humbled and honored to have you. I hope that you get something out of this webinar. We've put some time into producing these. We think the content is interesting and useful in the markets that we work in. So, and just want to say, if you have to jump off, or if you know somebody that would have loved to have been on the webinar that couldn't make it, we're going to post this after completion to our website. We've got a lot of other webinars posted on our website, www.barnhartcrane.com. And so lots of great material on there in case you missed our time together today. Okay, a little bit about myself. I'll be presenting today. My name's Van Thompson. I've been with Barnhart for nearly 15 years now. Have my degree in mechanical engineering, but I would say I am firmly a rigging engineer at this point, which is a little bit of mechanical, a little bit of civil, a little skosh of environmental and geotech, all mixed in to get what we call a rigging engineer around here. So that's a little bit about me, and we'll jump in to presentation. Okay, so now I recognize that a presentation that's focused on planning isn't exactly the most exciting thing you could ever hear about. Now, I'm not going to go into a cool new tool, not going to highlight a new innovative rigging method, but make no mistake, this topic is no less important. So that said, hopefully you won't need too many espresso shots to stay engaged. Now, what I do want to do today is paint a bigger picture than just load planning. And as we're going through this, what I want you to be thinking through is the idea of risk management. And at Barnhart, we define safety as operating at an acceptable level of risk. Now, you can't eliminate risk. And driving to the job site presents risk. Even walking along the job site presents the risk of stumbling and falling. The only way to completely eliminate risk is to not show up, and we obviously can't do that. Now, you expose yourself to risk to reap the rewards and advantages of what you're doing. So let's take the example of a power tool or something. A power tool, you run the risk of cutting yourself if it's a saw, or potentially electrocuting yourself. And so you could ask yourself, why would I ever use that power tool? Well, the reason you do it is because it helps you perform the work faster, more efficiently, with less work on your part. So when we start talking about planning and we talk about risk management, what we're talking about is doing everything possible that you can do to manage the risk associated with the work so that you achieve the best possible outcome. All right, so here's a basic review of what we're going to discuss. We're going to start out looking at poor planning and what can go wrong, kind of the ugly, the bad and the ugly, if you will. Then we're going to go from there. We're going to look at proper planning. What can go right? What are the advantages of spending time thinking through a load handling plan? Then we're going to look at the difference between a good plan and a bad plan. And then we've got some standards and guidelines that we're going to look at that help give guidelines, help give a path that you can go down when you're thinking through load handling activities. Then I've got a few scenarios that we're going to walk through that hopefully pull everything together. And lest I forget, no presentation on planning is complete without the immortal words of Benjamin Franklin. And I am sure y'all have heard these before, but I can't do a presentation on planning without mentioning them. If you fail to plan, you're planning to fail. Okay, so let's start by discussing what can go wrong when load handling activities aren't planned appropriately. Before we go any further, out of respect for other heavy lift providers, I'm not going to call out any companies, and I've marked out all the logos on any pictures that I use for these particular examples. Now, this isn't to say we shouldn't discuss lessons learned, and I'm not advocating that we sweep mistakes under the rug. On the contrary, we should use our failures to get better. And at Barnhart, we certainly aren't without our mistakes. I'm sure you could Google or YouTube Barnhart rigging accidents, and unfortunately you'd find some things would come up. But we use those incidents to get better. We educate our teams on what went wrong. We put in place actions to keep them from happening again. We strive to learn from our mistakes so that we don't repeat them. Now, the 3 pictures that I'm showing here are from a simple Google search. All I did took me about 4 seconds. I went into Google and I typed rigging failure, and these came up. And I don't know if anyone was injured. I hope they weren't. I don't know if anything was damaged. Well, obviously things were. But what I can tell you is it's the worst nightmare for any heavy lift or heavy transport provider to have an accident like this that causes harm to their crews or to the public and damages equipment. All right, so when we ask ourselves the question of what can go wrong, the most obvious answer is that people can get hurt, and we can't understate this. At Barnhart, we have a saying that our work is not dangerous, it's just terribly unforgiving. The safety of the crews and the public around load handling activities should be held paramount, which is why these lifts need to be thought through before anything moves or anything floats. And when someone is hurt due to a rigging accident, the most obvious consequence is that individual at best has a long road to recovery, or at worst, they lose their life. However, should also be considered is the effect that the accident has on a company's ability to even bid more work. So OSHA recordables, they affect the published incident rate of a company. And many industrial sites have got limits on which subcontractors can bid on work based on that particular subcontractor's incident rate. So the more accidents you have, the higher your incident rate goes. And if your incident rate is too high, it really doesn't matter what service you could provide. You could view yourself as the best in your industry, but if your incident rate is too high, you won't even be allowed to submit a proposal. Now, in some instances of poor planning, you may get lucky and you may not hurt anybody, you may not damage any equipment, but you may not hurt anybody, but you still run the risk of damaging the piece that you're moving, the equipment that you're using, or the work site that you're in. And no rigger wants to go to their client with their hat in hand after they've damaged the load. And no client wants their shiny new piece of equipment to be damaged, dinged, or destroyed. So these are things we've got to think about. We have to make sure that we're not injuring the public, we're not injuring our crews, that we're not doing any damage to the equipment that we're lifting or the site that we're working in. And so as we keep moving through these things that can go wrong with poor planning, it's worth mentioning that there are times when poor planning doesn't necessarily lead to someone getting hurt or it doesn't lead to something being damaged. In fact, there's many times in which the skill of our field crews thankfully prevent these issues. But what they aren't able to prevent is load handling activities that take longer than expected. And we've all been there. You've got to move something from point A to point B, but you don't take into account an obstruction. You miss a cable tray that wasn't lifted as high as it needed to be. You miss a pipe that wasn't removed. There's things that exist on the sites that can really interfere and delay the load handling activity. And by the time you alert the client to have the obstruction removed, or if you come up with a workaround, you've lost valuable time on the schedule. And the fact is that in the industrial construction market, and in really many other business areas that matter, time is money. And the more time you spend on a load handling activity, the more money that's flowing out the door. Now, I'm sure that this isn't an exhaustive list that I've got up on the screen. And the last point that I want to make about what can go wrong with poor planning is the effect that incidents have on your reputation and public perception. And for the heavy lift, heavy transport provider, the effect of accidents is straightforward. You run the risk of being known as the company that drops things. But there's also a risk for site owners. if accidents happen on your site, you run the risk of being known as an unsafe site, or even worse, a place that doesn't value the well-being of people. And the thing to remember as we've gone through all of these things that can go wrong, and there's many more that we haven't mentioned, is that these horrible outcomes are preventable. And so we're going to spend the rest of our time together talking about how we can prevent them. All right, so we've looked at the bad and we've looked at the ugly. And let's take a moment to consider the payoff for proper load handling planning. And this picture is from a project that we did a few years ago, in which we used our modular lift tower and strand jacks to set various components of a really large press section. The project involved just a ton of coordination with the site owner, other contractors that are on site, as well as the lifting and setting of several million-pound plus pieces of equipment. Now, the reason I love this picture is you've got everybody that was on site, both Barnhart personnel and then other contractors. They're all there, and if you were able to zoom in, you'd see that many of them are smiling. And when you can get an iron worker to smile, you know you're doing something right. All right, so if we were to sit around a table and talk about the things that could go right with proper planning, I'm sure we'd come up with a list that's way longer than what I'm showing on the screen. But for the sake of time, I've narrowed things down to 4 main advantages or outcomes, and we're going to go through these. And the first is obvious. You have a safe lift in which no one gets hurt and nothing gets damaged. And this is the obvious goal whenever you're moving equipment around. The second outcome, a reduced schedule, can take a little more work but can have substantial benefits. The sooner these sites get back to production, or the sooner they start producing, the sooner that they're able to show a return on the investment they made in that particular piece of equipment. And beyond that, if your field crew is working in tough conditions, the ability to get the work done safely, but also ahead of schedule, is massive. The third point to consider is that proper planning has the potential to limit the amount of changes you have to make to a work area. So if you're building a plant or facility, many times you can fit equipment installation into opportune times in the construction schedule so that you don't have to go back and take out things that crews previously put in place. And finally, the last point that I'll make is that when you repeatedly think through load handling activities, when you properly address the risk point, and you regularly, consistently don't damage equipment, don't hurt people, really serve clients well, you quickly garner the reputation of a reliable organization that can be trusted with load handling activities, or a site that people look at as a standard bearer for safety. Okay, so we've talked about the consequences of poor planning, and then we talked about the benefits of proper planning, and I'm sure that we can all agree that we want to put together good load handling plans. But the question you may be asking is, well, what goes into a good plan? We're going to spend the rest of our time addressing that particular question. A good load handling plan starts with the latest and greatest information. And this can take some work to get. It can take reaching out to site owners. It can take reaching out to equipment suppliers. You want to make sure that you have the latest and greatest information when you're putting together a plan that a field team is going to execute. You also want to make sure that that plan is reviewed by a subject matter expert. Now, within Barnhart, when we put together engineered plans, which we'll talk about, all of our plans are reviewed by senior engineers. But there are times when plans happen verbally, when you have scenarios in which the most efficient way to communicate the risk is person to person. And that's when the reviewer needs to be somebody that's experienced as well. So when talking through the plan, you need to make sure that other people feel welcome to give their input, to raise their hand when they don't understand things or when things don't sound right. a good plan is also well communicated from the lift planner to the lift director, and then from the lift director to the crew. So communication is key. And again, in some cases, that communication is done verbally. In some cases, that's done in written form, either via a written lift plan, drawings. There's many ways to communicate lift plans, but they have to be communicated clearly. At each step of the communication, the risks are assessed and identified. People need to make sure they understand their roles, and a plan of action is implemented if the plan were to change. And I also want to note that a good lift plan makes otherwise complex activities seem simple by providing the crew with step-by-step plans of action that reduces impulsive thinking on the fly and, again, brings clarity. That's what you're after with a good load handling plan, is a plan that focuses on details and brings clarity. And now that we've gone through the advantages of planning, we've pointed out the differences between a good plan and a bad plan, you may be thinking, well, I know what the difference is, but what specific things should I be considering when developing a load handling plan? And lucky for us, there's industry standards available that address that specific question. The primary standard I want to point out is ASME's P30.1 standard. This is planning for load handling activities. Now, the growth and development of industry, specifically the heavy lift, heavy transport industry, is what has led the ASME to implement this standard back in 2014. And this standard provides protection for life, limb, property through guidance to site planners, personnel, and users. The P30 standard is great, and it's certainly worth a cover-to-cover read. However, for our time together, I want to point out two main areas of the standards: the review considerations and how the standard categorizes load handling activities. So, the list of the review considerations that the P30.1 standard puts forth they're relatively self-explanatory, but I want to run through them for clarity. Let's start with the hazards to persons. And the key thing to think about are whether you're lifting people in a man basket, whether you're lifting over public areas, and if the assembly or execution of the activities puts crew members in pinch points. So when you're looking at a load handling activity and you think of hazards to persons, these are the things to consider. The next consideration is hazards in proximity to the work area. And the big thing with this consideration is power lines and how close you have to get to them. You also need to ask yourself and make sure that you aren't setting your load handling device over underground pipes that could be crushed due to the weight of the equipment. So what are you supporting on? Moving on, the next consideration is the complexity of the load handling activity. And there's definitely some subjectivity here on what's considered complex. But the good part of this standard and the good part of thinking through it is that it really makes you question how involved is the load handling activity. The next consideration is environmental impact. So things to consider here are things like, will wind or ice be a factor? Or how about the temperature during the lift? Are we going to be operating in extreme temperatures one way or the other? How will this affect the crew? The load handling equipment capacity is a consideration that needs to be thought through. Do we know the capacity of the lifting device? Do we know how to properly interpret that load chart of the equipment? Crane charts in particular are very dependent upon the configuration we're using. So you've got to be sure that you're using the right chart for the right configuration. And then, are we close to maximum capacity of the load handling equipment? Are there other factors that need to be considered, such as dynamic loading? The next consideration is rigging capacity. So you've thought through the capacity of the equipment that's actually doing the lifting and lowering, or the moving. Next, you've got to think through what a attaches the piece to that load handling equipment. Are we making sure that we know the capacity of the slings, the links, the hoist rings, all the different rigging tackle that you may be using? And then things like, are you thinking through sling protectors if you're rendering over edges? Making sure you know the capacity of your rigging and how to use that rigging properly is key to a successful load handling plan. Next is adverse commercial impact. So this gets you thinking, are we moving something that will have significant replacement time, or is it irreplaceable? If the activity takes longer than expected, how does that affect schedule? Are there liquidated damages involved? These are things that need to be considered when you're starting to think through the commercial aspects of your application. Next one is site requirement unique to load handling activity. And this refers to site-specific settings that affect how the load handling activity has to be approached. And prime examples of this are nuclear power plants, seaports, and anytime you're working on MSHA sites. The last consideration that the standard goes through, recommends, is thinking through repetitive lifts. Complacency can be and is a leading cause of injury and property damage. If repetitive lifts are required, it's important that plans be developed to ensure that field teams are paying attention to the details and managing that risk. So once the lift planners take these considerations into account, then we can start to properly assess what type of load handling plan is needed. And so let's take a look at the two categories that the P30 standard outlines. They divide them up into two categories. One is standard lift plan, and the other is critical lift plan. So we're going to dive into those. And the definitions that you see for these two types of lift plans, these are straight out of the standard. And if you read them, then what you'll notice is there's some ambiguity here. It's not clear cut. It's not, there's some subjectivity here, and there's a reason for that. So why the ambiguity? And you may have noticed that the definitions essentially say the same thing, and that a critical lift simply exceeds lift plan criteria. And the reasoning for this is to get the planner thinking about the specific job at hand, because no two jobs, no two applications are the same. The field crew, equipment, customer, the job site, they're all different within every job, and they require different lift plan needs. And so a load handling activity may be standard for one crew, but could require a critical lift plan if you had an inexperienced crew. And what about if you're hoisting materials and things like over a river? And this lift may seem routine, but the potential for environmental impact calls for a critical lift plan. So again, this is how it starts, everything coming together between the considerations you have to think through and then how you plan that work. In essence, the lift planner needs to evaluate the considerations for each specific job in order to develop an adequate load handling plan. Okay, so here's a flow chart that ASME P30 standard provides, and it serves as guidance for choosing the appropriate load handling plan. It starts with reviewing the considerations that we went through to help you determine what type of lift plan. And then after you evaluate the considerations, then you can categorize a load handling activity as, again, standard or critical. And a standard lift plan can be verbal or it can be a basic written document. A critical lift plan, on the other hand, is either a basic written document or it's a detailed work package, such as an engineered lift plan. We've got some scenarios that we're going to go through shortly that will help flesh out the differences in those different type of lift plans. Now, I know I camped for a while on the P30 standard, and for good reason. It's a great resource, really helps you think through the big picture planning for load handling activities. but there's two other resources that I want to draw your attention to. And we're not going to go into detail on these, but they're definitely worth researching on your own. The first is a standard that ASME put out that covers load movements in nuclear facilities. Now, this standard replaces, but still consistent with, the old NUREG 612 standard that came out in the mid-'80s. And MNL-1-2019 is the name of the standard, and it's been updated to reflect current industry standard practices. And quite honestly, in my opinion, I think it flows better than the dated NUREG 612. The other resource is a book I mentioned before on these webinars, but it bears repeating. Keith Anderson's Rigging Engineering Basics is all about helping people ensure that lifts are performed safely and efficiently. But in particular, however, the book's got two chapters, I think it's chapter 24 and 25, that are dedicated entirely to things to watch out for when you're planning load handling activities. I highly recommend snagging a copy of both of these resources. Okay, so I want to end our time together going through 3 different load handling scenarios and how to approach them. These are real-life scenarios that I hope will drive home the importance of proper planning and give you an idea of the different types of plans that are acceptable for different load handling activities. So a first scenario that you can see involves moving pipe sections around on a job site. And again, this particular picture is one that I found on a Google search. And as the picture shows, the sections, they come in various lengths. They've been pre-staged, and we're moving them using a rigging attachment that fits on the end scoop of a backhoe. As leaders and lift planners, we need to think through this activity and review the considerations so that we can determine the most appropriate load handling plan. So let's think through it. All right, so we start with hazards to persons. So this individual, they're outside. For the sake of our exercise here, we're going to assume that they're trained, that they understand the idea of pinch points, and that this activity that they're doing, moving these pipe sections around, typically doesn't put them in the line of fire. But we do want to make sure, we do want to make sure that he's careful when he's around the other pipe sections. Again, he may back up and there'd be a pipe section, trip, fall. So definitely want to keep that in mind, and we'll talk about that momentarily. Okay, the next consideration, hazards in proximity to work area. It's a relatively isolated site. There's no power lines. All the power lines are on the outside of the site. They're not running across the work area. We're laying underground pipes, so we've got a pretty good understanding of the support surface that we're working on. But if we do have to work in trenches, we want to make sure that the individuals are trained in trench safety. Okay, moving on. Complexity of the load handling activity. It's a relatively straightforward task. We're lifting pipes, they're transporting them, and then they're lowering them into a trench. Standard rigging practices. Okay, environmental impact. It's a sunny day, visibility is clear, the conditions are dry, the site drains well. Pretty minimal risk when you think through the environment that they're working in. The load handling equipment capacity. Now for this particular application, the backhoe that they're using, I looked it up, you can lift over 3,400 pounds from a 13-foot radius. Pipe sections that are about this diameter typically weigh around 50 to 75 pounds per foot. So as long as the sections are less than 45 feet, which they are, then you're in the clear. So don't have to worry necessarily about the capacity of your load handling equipment. Rigging capacity. The clamp capacity that they're using here is rated for 5,000 pounds. So again, that's going to be more than what the load handling equipment can handle. And it's designed to, as you lift the load, it clamps tighter. And so definitely the right tool for this particular application. All right, moving on. Adverse commercial impact. These pipe sections are standard. The schedule that we're working in is pretty reasonable. So again, minimal risk when you think through this consideration. Rounding things out, unique site requirements for the load handling activity. This is not a site that they're going to have additional site requirements, so we don't particularly have to be concerned with that. Repetitive lifts. This is actually a big one for this type of activity. This definitely fits the description of repetitive lifts, so we need to make sure the team isn't complacent. Okay, so based on our risk assessment, I think we can all agree that for this lift, for these lifts, this situation is best described as standard lifts that can be performed potentially under a verbal lift plan by qualified individuals. Now, there's one thing that's worth emphasizing here, and that's the idea of a qualified individual. And I want to take a minute and just reinforce the importance of training your field crews to rig properly and understand the risk associated with the work. At Barnhart, to help with this, we've developed standard operating procedures that outline best practices for the various scopes our teams find themselves in. These SOPs help ensure alignment, consistent service, and are a means that we use to manage risk. Another tool that we use is a job hazard analysis, or a JHA for short. And these are tools that our field leaders use at the start of shifts or before we make major lifts to help ensure that the team is engaged and the risks are managed. So in our scenario that we went through, the field leader in this particular case would want to use the JHA and use that time as a time to talk about the tripping hazards. They want to discuss pinch points and where to stand. And they want to make sure the team knew not to go into the trench without trench walls, and they want to make sure that the team isn't complacent after they've done 10, 15, 20 of these lifts. Okay, so moving on to our second scenario. Our second scenario involves lifting an 18,000-pound concrete vault. You're lifting it off of a truck, swinging it 90 degrees, and then setting it into a hole. And we're not going to go through each consideration like we did on the first one, but for the sake of training, let's say we did. And we highlighted the fact that the crew members would need to be working close to a hole, that power lines were in the vicinity, and that we're operating near a main road. Now, even with these factors, this is still a relatively straightforward operation. However, to ensure a successful lift and make sure these considerations are accounted for, we classify this as a standard lift, but one that would require a written lift plan. At Barnhart, we've developed standard lift plan templates, and you can find similar ones like this online. You can find a copy of one in Keith Anderson's Rigging Engineering Basics. But we've developed this standard lift plan template that our project managers, sales leads, and field leaders can complete. And these documents walk the individual through key considerations such as rigging, rigging capacity, details about the load, and the configuration that the load handling equipment is going to be in for the particular lift. And we also couple these types of lifts with drawings that ensure proper crane placement and give the client a visual representation of our plan. Now, these drawings were created using 3D Lift Plan, which is a web-based program that has got manufacturer-approved models of cranes, rigging tackles, and can be done by project managers and sales leaders alike. And we use these 3D lift plans to make sure that we're communicating clearly. And the other nice part is that you don't necessarily have to engage engineering resources, but yet you get a quality drawing that's got the information that field teams need to ensure that the risk is managed. Okay, now our final scenario is going to be more involved. Our first scenario involved pretty skill of the craft lift plans, lift and pipe sections. Second scenario is a little more involved, crane layouts, picking up, swinging, setting into a trench. This one is like I mentioned, it's more involved. It involves the removal and replacement of 4 340,000-pound vertical reactors that are situated in the middle of a live refinery. Now, for this particular instance, space was limited. You can see these 4 reactors right here are the ones that we were charged with lifting, and they're positioned behind this large stack. And the area in front of the reactors, which is shown in the blue box, was less than 40 feet by 80 feet dimensionally. And then the alleyway that we had to remove them, shown representing this green line here, was only around 35 feet wide. Now, if you were to go through and review the considerations that we talked about on this scenario, I can just about guarantee that all the alarms and all the red flags would go up. We don't have enough room for a crane, which means we have to use a non-standard lifting arrangement. The work takes place during a turnaround, which means the schedule is absolutely paramount. And we've got to trip the reactors from vertical to horizontal to get them out of the area. Again, a non-standard activity. So when we look back at our flow chart, it's easy to see that this would classify as a critical lift plan, and what's more, that this particular activity would require a detailed work package and copious amounts of engineering to figure it out. So let's take a minute and let's look at the engineering plan that was put together for this particular project. So here's an overall layout, and you can see that our lifting device, we didn't have enough room for a crane, but what we did have enough room for and what we came up with is strand jacks mounted on top of our modular lift tower, and that modular lift tower was positioned on our skidding system so we could index from reactor to reactor to reactor. Now, what you'll notice is the strand jack is actually positioned outside the base of our tower. And so to maintain stability, what we had to do, and what you can just make out in this drawing, is counterweights that we had to put on the tower to maintain stability. This next drawing is one of several drawings that shows specific details that were critical to the project. So it shows things like our track layout that the tower slid on. It shows connection between the upper girders and our strand jack, and it shows connections between the lower counterweight stack and the rest of the tower. And here's another layout drawing that shows the gantry track that we used to support the gantries that actually tailed the reactors. And you can see we didn't have a lot of space in that alley, and we had to make sure that that we tailed the vessels at a particular angle relative to the tower. So normally we like to tail things 90 degrees to our lifting device. In this case, we had to be at a skew. And this last drawing that I'm going to show, it shows the transport arrangement of one of the vessels on our SPMTs. And the key thing that we're calling out here is the zoning configuration of the trailer and the location that the field teams need to position the reactor on the trailer to make sure we've got optimum stability. Okay, now the last several slides that I went through, the last drawings I went, they make up just a sampling of this entire plan. In total, our design package consisted of over 25 drawings and over 17 different calculation packages. But in the end, the effort of all that planning was worth it. And here's a couple shots from the actual lift. So you can see our tower erected, lifting over this first reactor, getting ready to lift it up. And the picture on the right is after we've grabbed a hold of it with our tailing gantries and have started the tailing operation. Pretty slick job. And then here's a picture of the vessel on our transport arrangement. And this project and this scenario that we walked through, while it's complex and it's very unique, it really does represent the value of planning. For this particular project, we had no safety issues. No one was hurt. Everybody went home the same condition that they arrived at the beginning of the day. We didn't have any equipment issues. We didn't do damage to any of the reactors or the customer site. And we were able to swap out all 4 reactors, which is 8 total lifts, in 9 days, which is well ahead of the customer's schedule. We very much consider this a successful project, both for Barnhart and for our client. Okay. Well, that's all I have today. Again, I hope you were able to see how looking at each particular load handling activity, walking through that list of considerations, thinking about what can go wrong, should drive you to put in the appropriate amount of planning to make sure your field crews are trained and that your plans clearly communicate the risks and the details needed to manage those risks in a safe and efficient manner. Again, I know that there are countless other things you could have spent your time doing, but you chose to spend it here with us, and I greatly appreciate that. Would love to take some time to answer questions, so please feel free to type those in the Q&A box. And Mark, I don't have, I'm struggling to see those questions.
I don't have any questions right now. There should be a Q&A box down the bottom.
All right, now I got it back. Let's see. Okay, here we've got a question. So how do your load handling plans tackle ground conditions? Do you analyze the ground for the loads you put down? That's a really good question. So our load handling plans, they typically address everything from the bottom of our equipment and up. So what we'll do is we'll indicate the loads that we're putting down, but it's the responsibility of the site owner to ensure the ground can support the loads. And I think this is detailed out in OSHA's 1926. I think it's section 1402. They put the ground responsibility to what they call the controlling entity, which is the prime contractor or the site owner. Hope that answers that question. All right. Oh, all right, we got another one. When do you have to have lift plans stamped by a licensed engineer? Good. That's another great question. I should have addressed that. We, at least in Barnhart, we don't have any hard and fast rules on this. It's more of a case by case, and in particular, it's client driven. So, most of our nuclear and our refining clients, they require PE sealed packages, and we've got engineers that are licensed. We've got engineers on our team that are licensed in most of the states that we work, and those states that allow us to get a certificate of authority. In states where we don't have a licensed engineer or that we're not allowed to get a certificate of authority, we've got good relationships with third-party firms. So, but to answer your question, it's for us, what we found is it's more client-driven than anything else. All right. Well, everyone, I think that's all we have. Again, if you, we'll be posting the recording of this webinar to our website, so please feel free to check out our website, www.barnhartcrane.com. And if you have any questions that you think through, feel free to shoot me an email. My email is posted here on the screen. So with that, I appreciate your time and have a great day.